Hi, this is Rick for EDU Mobile. A little bit on in this demo about inheritance, but I also want to look at the copy behavior of reference types. And we're going to play a little bit with as well, that casting operator for instance types. So I have a class here, point. It's a very simple point class. X and Y are doubles. And then I have an initializer, X as double, Y as double. And the initializer just sets self.x to x and self.y.y. The only reason here we have to use self is because obviously the parameters are named the same as the stored properties, and the parameter name takes precedence, so we have to resolve the property by using self dot. Then I have a line which has 2 points called start and end. The init, of course, must be there because start and end, just as x and y in point, are not initialized. So we've defined this init to be from as a tuple, to as a tuple, and then start is a point x from 0, y from 1. We can use the dot and then the index into that tuple syntax to do this. And end, similarly, is point x to 0, y to 1. So now we've got a line from one point to another. So now we have a class math line, and in this case, we're inheriting from line. Now when we inherit, we get lines initializer, and we also get start and end. So I don't need any other properties. I've got the starting point, and I've got the ending point. But I do want to be able to calculate a couple of things. I want to calculate the length here and the slope of the line. So here, in my calculated property length, which is a double, I have a getter defined, and we return the square root of the square of the difference in the x's plus the square of the difference in the y's. Now, you may be looking at this and saying, well, okay, this is my square root function, obviously. Pal is a function, a library function, that gets the power of a number, and it's a certain power. So here I'm using pal to get the square of a number. In Swift, like in C and most other C-based languages, there is no square operator. There is no raised to a power operator. So we have to use the pal function in this way. All right, so that's the line. That's the length of a line. And the slope of the line is a calculated property that is a double, and its getter is return delta x over delta y. So the difference in y's, delta y over delta x, the difference in the y's over the difference in the x. And then here, for later, I want to provide a function that returns a new instance. If I copy a math line, I'm going to get a reference to that same math line instance. And I don't want that in this case. I may not want that. So I'm going to provide a function called copy that just copies it out and returns a new line. And it copies the existing line. So this will perform a shallow copy. So I've declared my line to be a math line from 2.5 to 6.8. And I've worked with my properties and my declarations so that this makes sense. Passing a tuple and then inferring it as a point. So I can get, obviously, myline.length, myline.slope, myline.start, and myline.end. I've kind of diddled with the numbers here so that this is a 3, 4, 5 triangle. So my length is going to be 5. My slope is 0.75. My starting point and my ending point I get just out of the properties of the underlying line that I'm inheriting from. All right, so now let's declare a no math line as a reference to my line, but inheriting or actually an instance of line. So I'm inheriting the properties of my line, but not the length and slope methods. So as here is performing an upcast. When we do this, we know it's always going to succeed as long as we know that the type of my line is a subclass of what we're going to use the as with. So we're performing an upcast. So we can get no math line start and no math line end. They are 2.5 and 6.8, just as they were in my line. This is a deep copy, though. So if we try to check, is no math line a shallow copy, then it won't work, but I'll show you that in just a second. There's another thing I do want to check here. Since we're copying my line, should we not be able to get the slope, let's say, of no math line? Well, let's try it. No, because we have cast it as a line. And a line, if we look up here, doesn't have a slope or a length. So if I tried to get the length here, I couldn't do that either. And it says that line does not have a member named slope. So is no math line a shallow copy? Well, if I alter start on no math line to, let's say, 5.3, then we get the no math line start is 5 and 3. But if we try to get my line start, it's 5 and 3 as well. So we have altered my line by altering no math line, even though no math line is a line and my line is a math line. So this is a copy of a reference type, and it gets a reference to the same instance. Now that's why I define the copy function. And so if I take a copy var some other line equal my line copy as line, and again I'm performing an upcast, now I can say my line start is 5.3, some other line start is 5.3, but now I'm going to change some other line's point to 9, -7, and if I check my line start, it's still 5.3, but some other line start is 9, -7. So this is a shallow copy, and I've actually gotten a new instance of the class as a line, upcasting it, and anything I do to some other line is not going to affect my line at this point. So get the difference between a shallow copy and a deep copy. And then we also see the as operator here used as an upcast. Thank you very much.